So chord construction, and I'm not saying that's a perfect breakdown of it, by the way. I'm trying to give some general ideas as to why that thing that we're going to simply accept going forward may be the way it is. And if you want to dive deeper into that, then dive deeper into it. So triads and extended chords like seventh, ninths are built on the early harmonics. So tuning systems. So just intuition, just intonation is based on exact harmonic ratios. However, equal temperament slightly adjusts these to fit 12 equal divisions. So in other words, you've got this a little bit of an issue here because it didn't fit perfectly, and we liked in our human world, right? We like things to be symmetrical, and something didn't come out that was exactly symmetrical. And so then we wanted to make it symmetrical, which again is an interesting tweak that happened because that's a little bit slightly different than what's happening naturally, which might give you some ideas what you might want to do musically, because that could give you an idea to untweak it and say, well, this is going to sound more natural maybe if I did that versus artificially symmetric, which is what we human beings like to do. Take something, we're going to take trees and whatnot that are growing, there's vines growing out all over the place, and then we put them in a nice symmetrical line in front of our house because we like it in a straight line, right? So that the balance between symmetry and messiness is something to play with. So the timbre, the tone color, so the strength and presence of different harmonics determines how instruments sound unique. So notice that we have this series that's happening here, and there's a ratio that's happening, but the ratio is also always whole ratio. So you would think that still gives us variance that happens between different instruments, which is interesting because that's what's going to give us the different feel of different instruments, which again, you can imagine the big puddle with the big ripple coming from the rock, and then all the other ripples are going to be slightly different on the other instruments. And with a guitar in particular, that becomes something that you can do uniquely on the guitar. And that's something possibly that AI might still have a little bit of trouble doing. AI is getting quite good at simulating things that are quite complex because they're layering different sounds on each other to simulate the ripple that's basically happening. But it's going to be more difficult on certain types of instruments like a guitar, you would think, where you can manipulate the timbre all over the place, right? You can put hammer-ons, you can bend the chords, you can slide on the chords, you can put vibrato on the chords, you can use your right hand to pick the chord on different areas within the string, which is going to give it basically a different feel to it. You can use muting techniques. All of those things, although producing the same overtone, will likely produce a wide variation of timbre, even though it's coming from the same instrument. A little bit more difficult to do that on like a piano, for example, because although you have pedals and whatnot, and you got the force of how hard you hit the key, and that does give you a lot of variance. Not maybe quite as much though as, of course, a guitar, where you can do all this crazy stuff. You can actually move the guitar around. You can hold it to your body. You can put it away from your body. If you put electronics in there, then of course you're all over the place on these different variants that you can do, even though you have the same basic kind of overtone. So instrument design. So brass instruments use the harmonic series directly. String instruments use harmonic flageolet tones to divide strings into equal parts. So let's think about the guitar in more detail. So visual representation, imagine plucking a string on the guitar. So let's say we had this one long string on the guitar. You can kind of imagine in an analogous way as dropping the rock into the puddle. So it vibrates as a whole fundamental. So you can imagine the whole string, if you pluck it, vibrating. The whole string just going back and forth. That would be what we can imagine the fundamental. However, as that is happening, similar to multiple other ripples, it also vibrates in halves. So if we cut the string in half, if I plucked this whole thing and I wasn't holding down any frets, then you can also imagine like the middle of this thing is going to be split, and this side is going to be vibrating and this side is going to be vibrating opposite, like a sine wave to each other. So the whole thing is vibrating with one big vibration, and each side is vibrating opposite to each other, and in thirds. So the third harmonic, each division creates an overtone that stacks. So you can also imagine the string broken up into thirds. And you can imagine that those thirds are going to be vibrating opposite to each other. So similar to the rock that drops in a pond where you get one big ripple and multiple different ripples, when you're thinking about a string, analogous, the entire string is waving one big ripple, and then you get smaller vibrations of the string as it is subtly broken into halves, vibrating separately, and into thirds, vibrating in thirds, which creates the different harmonics. Now, of course, if you were to put your finger up on the fretboard, what are you doing? You are, in essence, plucking a shorter string. That's all we're doing. So what's going to create the sound on the guitar? The length of the string and the thickness of the string is going to change the vibrations. So implications in ear training and composition: musicians learn to hear harmonics in tuning, orchestration, and improvisation, which is one of the things that's, again, crucial to the guitar. And I think that's really a cool thing with, in particular, the guitar, although to maybe a lesser extent, in my opinion, to other instruments as well in the day of AI. Because I think one of the things that might happen in the day of AI is simple beats can be simulated, and you can use AI stuff to kind of create music and even complex things. But there's got to be some kind of consistency, you would think, with the AI. Whereas if you get into this more kind of weird jazzy stuff that's bending strings or doing more things that are not exactly uniform, that might be something of more interest. I don't know, I'm just guessing as time passes, as people look for things that are more human-based, even though the AI is able to master more things. So it's kind of interesting on where like music's going to go and art in general is going to go once the AI can mimic what we've basically done in the past, right? It's compiling together the stuff that we've made in the past and spitting it back out at us in cool different combinations. So now the question, so now in the future, what's that going to do to our artistic goals, right? So it'll be kind of interesting. So composers use knowledge of the harmonic series to create resonance, blend, and natural voicings.